It's March again, and with it comes International Women's Day, the day we celebrate women, talk about their rights, recognize their impact on our lives, and acknowledge that they deserve a better future. But what happens after this day? Nothing. According to the World Health Organization, nearly 1 in 3 women worldwide have experienced violence. Additionally, reports from mental health organizations highlight that women are 3 times more likely than men to face common mental health challenges. Unfortunately, due to cultural stigmas and societal shame surrounding therapy in many countries, many women lack access to the support they need. This is where Harmonia comes in. Harmonia is an AI-powered mental health and emotional support chatbot designed to provide a safe, non-judgmental space for users to express their feelings and receive practical, empathetic guidance. By leveraging advanced technology, Harmonia aims to bridge the gap in mental health support, ensuring that no one has to face their struggles alone. The chosen dataset is a comprehensive PDF file that describes various mental health issues, focusing on violence, its types, and related situations in detail. It also provides guidelines for dealing with these issues. This dataset was selected because it aligns perfectly with the therapy-focused application, offering rich, structured content that can be transformed into a knowledge graph. The inclusion of violence-related topics and coping strategies makes it highly relevant for building an agentic app that provides actionable insights and support for users dealing with mental health challenges. The data was converted into a graph through a structured process. First, text was extracted from a PDF using PIPDF2, then parsed into meaningful sections using regular expressions. Next, Spacie was used to identify entities, e.g., people, organizations, and relationships, which were represented as nodes and edges in the graph. Additional nodes for therapy-related keywords, e.g., trauma, healing, were created and connected to relevant sections. The graph structure includes nodes for sections, entities, and keywords, with edges representing relationships like mentioned in, related, and next section. This transformation enables a rich, interconnected knowledge graph for querying and analysis. The graph is persisted and loaded into ArangoDB through a structured process. First, the persist into ArangoDB function connects to ArangoDB using a Rango client, creating the database if it doesn't exist. Next, the ArangoDB adapter class creates 2 collections: nodes for graph nodes, sections, entities, keywords, and edges for relationships. The persist method saves the NetworkX graph to ArangoDB by inserting nodes and edges into their respective collections, with sanitized keys for compatibility. Finally, the toNetworks method retrieves the graph from ArangoDB using AQL queries and reconstructs it in NetworkX format. The agentic app dynamically processes natural language queries using LangChain and Gemini. It employs 4 tools: keyword search for keyword-based queries, entity relationship search for entity-related insights, therapy resource recommendation for tailored advice and complex question answering, for hybrid queries combining AQL and QGraph/NetworkX. The agent, initialized with LangChain's conversational capabilities, determines query intent and selects the appropriate tool. For complex queries, it extracts keywords, retrieves data via AQL, performs advanced analytics with QGraph/NetworkX, and synthesizes a natural language response. This dynamic approach ensures accurate, context-aware answers for diverse user queries. Let's try Harmonia together. As you can see, there's a friendly description of Harmonia and some example prompts to start the conversation. For instance, we can share our feelings by typing something like, "I feel anxious all the time and it's affecting my sleep." Harmonia will respond with empathetic and actionable guidance.